This is Urban Sloan with Sanyo Denki. I'm a sales engineer. Been working with Sanyo Denki right at about 9 months now, and I developed a application solution that combines the Sanyo Denki Modbus RTU servo drive in connection with a Proface HMI that's supplied by a simple power supply. And this drive is connected to our Sanyo Denki motor that's driving a small actuator. In this case, we're using a THK actuator. And I decided to develop this solution because we had a few distributors who also sell Proface HMIs. And I thought it'd be a simple standalone solution for these guys to take to market. So what I've done is I've actually developed some custom screens, as you see here. The custom screens basically will trigger different Modbus address registers and allow the HMI to directly control the drive. So there's no PLC in this system. It's purely an HMI and a servo drive. So we have the very low cost automation solution. So in there you can see I have a servo enable button here where I simply enable the servo. You can hear the motor over here. It's got a ringing to it as well as the phone ringing in the background. There's a stop reset button. This first screen is just a simple jog screen or fine adjustment screen where I can do fine adjustments to the position of the actuator, as well as I can do some homing on this screen as well. So for instance, if I touch the low speed jog forward button, if you watch my actuator here, it goes ahead and goes where I need it to go. I can simply just stop it wherever I want. Also can return back to the home position for homing because I'm using an absolute encoder on this one. See, it goes back to the home position. You can also see here on the screen, on the template, there's a measurement of the actual position. When the servo gets in the actual position, the servo in position light also comes on. We also can do fine adjustments. These are pretty much our one-step moves, so we basically move a fixed distance. So I can do this is actually going to be 1 revolution forward. Doesn't move very far. Let's try a little bit higher resolution for it. So that's actually 2 revolutions forward. It goes a little bit further. Okay, we have some other screens here. Also HMI, because it acts as a master, you manually can change through the keypad. You can directly write to the registers, make all the changes right here on the interface. So you don't have to dial into the software to make the changes. Let me cancel this here. Of course, the drive we're using is an indexer servo drive. So basically, there's different point moves, what we call them, that you can make. You can make up to 254 different point moves in the drive. And you can execute them by simply hitting a button. It'll run a sequence of moves, or you can run an individual motion profile. You also can teach an individual point move. So if you were to move the actuator to a given position, you can simply teach that position in the drive, and it will store it in the drive's memory for later. You could actually pull up that specific point. So let's run point move 0. It's actually a pre-programmed sequence that I've already programmed into the drive using the free software. First I'm going to home it to make sure we're back in a home position, because we're using an actuator, so we have fixed limits basically. We don't have any limit switches attached to the actuator, but you can easily attach limit switches and feed those directly back into the drive. The drive itself has on the CN1 connector there, it has 4 inputs that allow for different triggering of over travel sensors, or triggering the start of a sequence, or to emergency, not necessarily emergency stop, but a stop you can easily trigger using some type of sensor. So here I pre-programmed a point move to kind of demonstrate our indexer capability. I've actually slowed it down here so you actually can see it. So when I trigger point move 0, you watch here. I just did a sequence of moves, and I can run that again so you can see it a little bit clearer. Just a general idea or a general concept. You can see here it moved it back to the actual position from where it began. Is off by roughly 2 to 3 pulses as it flickers back and forth. Um, there's also some alarm reset screens that I've also built in here, so if you want to visually identify what the alarm is, there's screens built in where it actually will list the alarm code with the corresponding way to fix the alarm. Again, same thing with the jog speeds and the one-step speeds. With each point move, you can actually pre-program the registers where I can literally dial into each register directly from the HMI, so I don't have to go back to my software to make adjustments. If I want to change my speed of point move number 0, simply dial on it. I can change the speed on the fly. Ideally, these settings probably would have been used. They'd probably be pre-programmed into the system, but it does give you a lot of ability to directly read and write from the registers. Alright, well, this is just the first rev of the Proface to Sanyo Denki Modbus RTU drive using, again, a single cable here for communication between the drive and the HMI, as well as a single power supply to power the HMI, and it's just got a single, in this case we're using 120 volt AC right into our wall. So very, very simple systems for just single axis standalone applications. Very inexpensive automation solution.